right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanagh is here. And we're going to dive into a very interesting topic today. We're going to talk about the modern data stack of observability and security. So, of course, we've got this modern data stack in the data world, the analytics world. We'll talk about parallels between that and the business intelligence environment that I've been tracking for longer than I care to admit, about 25 years or so. And our guests have been as well. We've got Eric Tschetter online from Imply, and my good buddy Mark Madsen from Third Nature is here as well. And we were just joking yesterday about the modern data stack of modern data stacks, because there are all these modern data stacks everywhere, which of course is in contrast to a monolithic architecture, which is the old-fashioned way of doing it, with the big guns, the very large vendors doing their monolithic stacks. And then modern data stack is a sort of way to decouple things and break it down. It does get a little complex, but it does open doors to do things in different ways and to be more component oriented, right? That's the other big thing that I thought was going to be even bigger last year, composability, like composable ERP and composable solutions. But with that short introduction, I'll throw it over to Eric Tschetter first from Imply to let us know you got a new product coming out and you guys are focused on Lumi. Is that right? Imply Lumi, like
Yeah.
Luminate. And you're basically saying that you're seeing in the industry that the security folks and the observability folks are looking for the same data. So why can't they just share that data easily instead of doing some lift and shift, right? So tell us about that and why you're going down this road.
Yeah, absolutely. Thanks for having me, Eric. It's great to be here talking about Lumi. But before getting into Lumi, I think uh, the interesting thing is probably the genesis of it and where we saw it and why we went after it. But to talk about it really quickly, um, it's Lumi right now is basically a decoupled data warehouse for logs. It's a log specific decoupled data warehouse. What that means, basically, we started out at Imply, we've been around for like 10 years or so. We've worked with a lot of people, and they've tended to kind of be either in the business intelligence world or the observability world. And what we realized from interacting with all of our customers, figuring out what they're doing, is that the business intelligence world is about 30 years more evolved than the observability world. And what I mean by that is business intelligence went from this transition of tightly coupled, vertically integrated decision support systems with Siebel systems and stuff like 50 years ago, eventually moved into a visualization layer with things like crystal reports and MicroStrategy on top of a database, talking 30 years ago now. And to today, the ETL layer is kind of pulled out. You've got your data acquisition layer with a database sitting on top and then a visualization layer of things. And so there's this three-layer cake. Now, that evolution, we believe, came about because that is what the buyer, what the user actually wants in data infrastructure. They want that decoupling, and they want to be able to pick and choose the best tool for the job in each of those layers. What we realized is that for our observability customers, they don't have that choice. Then people are kind of looking for that. They're trying to grab open source solutions. They're doing things, but anytime they just want to find a vendor to help them, what they end up having to pick between is a bunch of different verticalized solutions. If you talk to the Elastic company, they'll send you a specific vertically integrated Kibana on top of Elastic on top of Logstash. You talk to Grafana Labs even, that's going to be Grafana for logs, Grafana on top of LokiDB with open telemetry. You talk to Splunk, Splunk's got your Splunk UI on the Splunk index or on the Splunk forwarder. You go to someone like Datadog, Dynatrace, the cloud vendors, they're all walled garden cloud vendor, vertically integrated things. And what people really want, though, is that decoupling, the being able to pick. And we realized that, okay, if the market is going to force that, then it just makes sense to go where the market is going because the market always wins. And so what we've introduced is a layer. It's a pure data layer for logs. It's we focus only on being the data layer. We focus on compressing the data, indexing the data for query, and then the real insight here is that one of the reasons that it was easy to decouple in the business intelligence world was the adoption of SQL. But in the security and observability space, there is no singular lingua franca like SQL. There's a bunch of different things. There's Splunk has SPL, Elastic has its own kind of log query language. LokiDB has LogQL. You get into CrowdStrike, they've got CQL. Microsoft Sentinel has KQL. You've got all these different query languages, and different people use different things. And so there's a bunch of people saying SQL for observability too. So like SQL's even in the mix, and there's a bunch of different options,
Hmm.
but the users use what they use and they love it. And so the other part of this is the market always wins and the users always get what they want. And so what you have to do is you have to align with what the users are using and what they're doing, which means that the biggest difference is being able to support all those query languages on the exact same data.
Hmm.
And that's fundamentally what we're driving after with Lumi and with the decoupling of observability is we're a data layer focused on compression, make it the smallest possible, make the queries as fast as possible, integrate with whatever language the users are already using so that they don't have to change their workflow.
Well, yeah, it's very interesting. And I'll tell you, like one of my thoughts from years ago, thinking about different roles and responsibilities in organizations, large organizations, is kind of interesting that you have like governance, risk, and compliance, right? GRC is one whole space, security is a space, data governance is a space, observability is a space, but they're all looking for the same stuff. I mean, in
Mm-hmm.
particular, governance, security, and compliance, you're all looking for the same things,
Yep.
basically. I mean, they're different disciplines in the sense that they have a different objective, overarching objective, but
Right.
they're looking at the same behavior. So why don't, and I guess you just have
And
an evolution of industries, and that's kind of what you're talking about, right? Is that
yeah.
there was this evolution and then the market demanded certain changes to it, and that's why we wound up with this whole decoupling thing. I mean, I'm old enough to remember service-oriented architecture and fine-grained services and coarse-grained services, and it's like, we're,
Yeah.
the whole new movement now towards Kubernetes is not exactly like that. It's not like service orientation, but it's similar in a sense. But it's also very, very complex. And I think, frankly, Kubernetes is what caused the explosion of observability because all of a sudden you have this new engine that a lot of people
Uh-huh.
joke, the guy from what is it, Red Panda, Alex Rodriguez, I think his name is. He told me, he said, yeah, well, if AI ever, if AGI ever does happen, hopefully it'll figure out Kubernetes. I thought that was pretty funny. But that's kind of
Yes.
what you're saying, right? So you're trying
Mm-hmm.
to address what you see as a significant fracture really in the industry's
Right.
trajectory, and you're going to try to feed that as it evolves. Is that right?
Yeah, absolutely. And on your point about kind of governance and all that, they need access to the data. Security needs access to the data. Business analysts also need access to that exact same data. There's stuff in that data that's necessary for business analysts as well. And but each of these groups speaks a different language. Each of
Hmm.
these groups uses a different set of tools. Each of these groups has a different workflow, but they all need access to that same data. And so the important part here is it's not just, oh, I have data and you can query it, you align to what I'm doing. The important part is meeting each of those workflows, meeting each of those groups where they are, and making that one set of data available to each of them.
Yeah, right. Mark, I'll throw it over to you. I mean, what fascinates me about this industry is there is no limit to the number of different ways you can solve for a particular problem. And what do you joke about? Shift left. All the guys are talking about shifting left, and it's like, okay, whatever that means to this person or that. But there is something to be
Circle.
said for information architecture and designing for reuse, right? That's exactly what they're talking about, right?
Yeah. Yeah. I think that's a part of the maturation cycle that you're talking about. It's that you can have the one-off thing to solve the one-off problem for the one-off people, but when you start having to share, uh, whether it's BI and its consensus about what things mean or, how to determine just a simple calculation of, what does this metric mean? Well, that's a consensus, but to do that, you have to have the same definitions and the same shared underlying information to do it. And it's no different here if you have multiple parties trying to do things. But I think the other part of the maturation is just the technical maturation. When you have this new thing, well, especially now, it's like, okay, we're going to launch this. Let's say it's the observability stuff.
Hmm.
As a stack, or it's all tightly integrated and vertically integrated because you've got specific functions over specific data collected in specific ways, and it's easy if you just mash it all in there and custom build something.
Hmm.
But you run into scale issues, you run into uh, well, if you treat your customers right, you can grow really well, which Splunk did for a while, right? And then Splunk started screwing their customers by jacking up the prices and creating new licensing models, and it sounded just like Oracle. And they were saying, don't use Oracle to store logs, which I agree with. It's not the right answer probably, but then to do that, and you cost more than Oracle, and then they wonder why there's a revolt, and you have all these other things. And then you throw cloud into the mix as well, and I would say other Eric. Let's say Eric too, since Eric Kavanagh is on the right here. Uh,
Yeah.
one of the
Just call me
things.
Cheddar.
Yeah.
Cheddar.
Cheddar.
There you go.
Yeah.
Okay. But yeah, one of the other things about how this stuff evolves is just not just about cost, but it is about need
Well,
and
yeah,
evolution of that need.
absolutely. Like cost and need are incredibly important. I mean, that's the other thing you talk about. You mentioned the Oracle and the other and store logs in one versus the other, but uh, coming up to like the new choices that are being put in front of people right now, it's not like don't store it in Oracle, store it here. It's now that it's storing it in cloud.
Yeah.
It's like if you have a large data set that you need to have, you don't know how long you're going to have it, but you need it. And at some point in time, it might be incredibly important that you can do some investigation of it. But maybe right now you don't need to. Where are you going to put that? The answer that people have gotten to is basically the data lake, the cloud. It's throw it in S3, throw it in object store, throw it in something like that, where you're just kind of paying for bytes sitting around and working on it, and then figure out the querying later, figure out what's going on with it later is kind of the approach that people are taking, and like that works. But the once you put it there, now there's the question of how am I going to get it back out? How does it work with the tools? And the choice that people are confronted with, if they're used to using Splunk, for example, and they love using their SPL and Splunk and doing all their queries with that, and now the data they have VPC flow logs or some DNS based stuff flowing into cloud storage, and they suddenly need to look at that. The options they have are, okay, do I re-ingest this stuff into Splunk? Do I go and figure out how to run Athena and change entirely how I do my normal workload and start writing SQL? Do I find some other tool that does things, or what are the things that I can do? And fundamentally, like the data lake kind of concept has really stuck with people in terms of, oh, I just put my data in the data lake and it's all good. I'll be able to get at it. But that data lake, then the way you get it out also needs to align with the end user workflow. And if that end user is using Splunk, they want to keep using Splunk to access data in the data lake. If they're using Kibana, if they're using Grafana, they want to keep using Kibana and Grafana to access the data in the data lake. They don't want the choice of the data being in the data lake to now force them to like suddenly change everything they're doing, learn a brand new set of tools and a brand new set of things in order to get their job done. And I think that's the next level of the data lake. And that's why I talk about us as basically a log specialized kind of data warehouse or data lake.
Yeah.
You can think of it as a log data lake, but it's focused on the shape of a log and what a log actually means and how people want to interact with it. And I think that's a key element in the evolution of the data architecture.
Yeah, I mean, there's two really good points there, and they're the same points that originally drove, hey, let's use Hadoop, right? It was, hey, let's use Hadoop, but the real reason either had to do with certain types of processing, often logs, or storing giant piles of possibly useful data at a much cheaper rate. And
Hmm.
where it all broke down, and the reason they went out of business is that they tried to then they conflated storage with retrieval, and storing seldom retrieved data that you might have to then process down to make use of it is one problem. Daily use of the same information is a
Hmm.
completely different problem, and the cost of retrieval in those environments, and I translate that directly to, say, you're using Trino against S3 buckets, the
Hmm.
cost of retrieval is orders of magnitude higher because it's not really structured for that. It's structured
Right.
to cheaply stored. And
Yep.
and so yeah, get it in, get it out. And yeah, trying to find ways to balance those and make that possible. And I think that's, seldom used data, cost of storage, cost of retrieval, and then different people wanting to do it differently, like you're saying, is
Hmm.
is is a big piece. And then that gets into a difficulty, which I'm kind of curious about, which is okay, you've got multiple different tools and you've got a system designed to store that. Um, so what's the mechanism you use to sort of break apart that access layer in particular from the storage so that you can do the retrieval operations you want to do
Hmm.
without without like in the BI world without forcing one of two things. Either I schematize my data in a relational database, which people have done for so long nobody thinks about it, or I suck it all out and I put it into a file, a rectangular shaped file so that Tableau or Power BI, and then I employ an army of developers to build basically, we call them pipelines, but you're just creating 10 million files, which is very 1970s, but
10
that
million.
is, every single unique use is shaping that one little thing.
Hmm.
And that's not really a good answer. And neither of these two answers is particularly good for what you're talking about, which you alluded to but didn't really go into, which is log structured data is not well structured data like a
Right.
data model in an application. And so that
Right.
is the conflating factor that breaks the database stuff.
Yeah, and we're gonna pause for a commercial break, but we'll be right back. So Eric has a couple seconds to think about that answer. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, we're getting deep into the weeds of information architecture and retrieval. Yeah, that's right. You put data into a database because you want to get it accessed later. That's kind of an important part. So these are really interesting decision points to consider when trying to build your stack. So Eric Cheddar, I'll throw it back over to you from Imply. Mark gave you kind of a hard question there. What's your answer?
Yeah. So the question, just to kind of repeat it back, is you've got the data, and traditionally people have either schematized it, and then you have people arguing about the names of fields and what things should be where, and oh, doesn't align with that, and you've got a whole bunch of that, or you have a bunch of people doing independent pipelines, setting up things, trying to optimize for this use case or that use case or the other, and kind of where does it go from there? And so the question was, what's different about how we're approaching this? Um, and that is that I believe that it fundamentally, so the schematized approach, the SQL based kind of DML strict schema approach, makes a lot of sense for business analytics, for places where you're trying to have a consistent quarter over quarter view of what things are. You want to know that it's been analyzed the exact same way. You see it the same. There's no changing. You can trust that numbers over time are like consistently comparable. And that's incredibly important in that world because it has to be aligned in that way. In the log world, you have developers who randomly chose to write a sentence in their app and emit that out because it made sense to them. And maybe it makes sense to a couple other people working on that code base. but does it make sense to anybody else? Who knows? We'll find out later when someone has to actually look at it, right?
Hmm.
And that difference, and really the difference here is, okay, the central the data type itself is actually the key. And so the ways that people interact with logs, if you try to think of logs the same way you think of business analytics data, you're going to do it wrong because it's just not generated the same. If you try to do that, you're going to set up governance and like governance structures inside of your organization and try to tell people how to write log lines and what words to put in there. And developers are inevitably going to get it wrong. They're going to put the wrong thing in. It's not, you're not going to keep up with it. And that's because the log is a tool for a developer to see what happened. It's a tool to get a quick thing about, hey, this thing happened. I might want to know about that later. And so the log is, it's a schemaless item. But from it, you absolutely can pull out fields. And this has been actually one of the most successful parts of Splunk was schema-on-read. And so their whole take on it was you have the log and then you define a bunch of extractions and those extractions pull fields out of the log and then you can do things on it. And that's been a massive thing for Splunk kind of working with logs. And that notion of the log data is special. It has its own format. There's ways you want to interact with it. You want to do full text search. You want to look into things, but you also want to be able to extract fields and do analysis on them. And basically, once you think about it in those terms, you can structure the data. You can compress the data. When you're actually storing the data, you can compress it and structure it in a way that aligns with that usage pattern. And that usage pattern, then when you look at any of the languages, any of the things that people are doing to interact with logs, they're all incredibly similar. Like the languages all look very similar to each other because at the core of it, the data type itself is kind of dictating what people are wanting to do with it. And as we go wider in the observability space, and we've been talking logs a lot because that's what our product currently handles, but in observability, there's logs, metrics, and traces. Metrics also follow the same pattern. Metrics are a specific type of data that has specific access patterns that people tend to want to follow. And if you lean into the type of data that you're dealing with, you can do all sorts of things in order to optimize and work with that flow. And it's the same with traces. And so my answer to that is the reason it gets complex is if you try to think of all data as the same. But when you step back and think of the type of data that you're dealing with and the access patterns that people want on top of that data, the doors open incredibly to the types of things that you can do. And you can still get a very generic experience out of it.
Well, I guess I'll throw in just some thoughts about log files and why they're kind of hard to deal with. Number one, they can take any shape, like to your point, the developers just come up with something, some
Mm-hmm.
piece of text that will show up. And the other is, and I think this is probably the more interesting one maybe, is that usually log files say everything's fine. Everything's okay. It's like you get all these information that's like, okay, fine, 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 and then not fine, not fine. Like, well, okay, why is it not fine? Then you're into correlating things. Like, okay, well,
Mm-hmm.
why did this happen? And so you kind of have to place, everyone keeps talking about neurosymbolic, right? Neurosymbolic, which sounds like a fancy word for object oriented in a way. But do you have like, is part of your magic the ability to analyze the patterns of log files? Because that's what you really have to do is say, wait, okay, this log file went sideways. I now know there's a problem. Like that's kind of a challenge to then think, okay, from this point in time, let's trace back to over here and figure out what this thing did and all that. That's what you have to do if you're like troubleshooting, right? Does that make any
That
sense?
is, and that is, so that's actually the experience is built on top of logs. The experience is built to help people explore logs and understand logs and work with them, are fundamentally kind of focused on exactly what you're talking about right now. The query languages built on logs are focused on exactly what you're talking about right now. It's the I found something, now let me expand. Let me take what I learned from here and look over here and look over here and expand what I'm looking at in a very flexible manner. And that's actually why personally I believe that the reason SQL hasn't been used for logs is really, it's exactly what you're talking about. That sort of correlation, building SQL queries to do that sort of correlation requires a bunch of joins. You get into complex things. It's the declarative nature of SQL itself makes it pretty hard to think about what you're talking about. Like that sort of, I want to do this thing, and then once I get that, I want to do this other thing, and then once I get that, I want to do this other thing. Where when you get into the other languages that are used much more for logs, they have a much more imperative flow to them. They have but both SPL and KQL have a pipeline. It's a bash CLI almost style flow where it's piped commands one after the other. And they all also have features where like you can do a command and the result of that gets embedded into the actual statement of another query. And there's things like that that make it much easier to kind of iteratively explore and expand on the data, which is why they've gained so much kind of, so many people love them for the use case because they're aligned with what people are trying to do with logs.
Hmm.
Um, a bit more than the other. But I'm not saying SQL doesn't have its place. It does. It's massively like it is aligned as well. And really, our take isn't that one language is better than the other. Our take is actually that these languages exist for a reason.
Hmm.
And trying to pick a winner is not what the data layer should do. As a data layer, it's not our job to tell the end user the tool they should be using to interact with the data. It's our job to store that data in the smallest number of bytes possible, make it accessible in the fastest way possible, using whatever tool the user wants to
Hmm.
use.
Yeah, it's an enabling approach that you're taking. You're trying to
Mhm.
enable people to do lots of different things, and that's what you mean by decoupling, right? It's sort of
Yes,
disaggregating the stack, right?
right. And so that exploration, if someone's using the Splunk UI for it, if they're using SPL and Splunk for it, they should be able to continue using SPL because they already know the workflow to do that. They already know how to
Hmm.
use that tool to actually get at that stuff. If they're using Grafana for it, they should continue using Grafana to do that because they already know how to do that there. Or with AI, an agent an agent should be able to do it. And if an agent knows how to do it with SPL, great, it should be able to do that. If it knows how to do it with SQL, great. From an MCP server perspective, if you support all the languages, you could just be like, hey, these are all the languages I support. Agent, interact with me however you want.
Hmm.
Go at it, and you can kind of enable those higher level use cases, and that's really the decoupling that exists in the observability and security world. Is the data layer's job is the unit cost of data, the speed of access, and then the integration with the interaction layers. The interaction layers
Right.
are the things that really help people do the exploration. They're the agents, the AI, the UI, the visualization. That's the interaction layer. And the data layer should be completely agnostic to that. And that's really what made data layers successful in the business intelligence world. But all they had to do was implement SQL over there. And SQL
Hmm.
was the way that they became unopinionated. Where in the security and observability world, there's more languages.
Yeah, and I think, that there's more languages because there's different problems.
Mm-hmm.
There's there's querying known things or linking to things. I mean, the two core aspects of SQL are expressibility and being able to refold things, right? Three different tables, four different tables, bring a new one in, it's all joins. Link,
Mm-hmm.
link. But then, logs like Eric was talking about, fine, 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 not fine. Often you're searching for anomalous events and filtering things down and generating a set that you then use for something else. And, then, that sort of imperative flow of get these things, now go look for these other things.
Mm-hmm.
Oh yeah, I didn't find any of those other things. What else did I find? Right. And that's a very non-retrieval relational database way of doing things. That's more of a search engine way of doing things or a correlation engine way of doing things. And
Mhm.
what I'm curious about then is you have these different tools who want to express, however they express
Mhm.
their search, their query, their scan correlate. Um, Typically, the language that you use to access the data is pretty tightly linked to the engine that executes against that data, right? The relational engine is like, I take diesel fuel, so I'm optimized this way.
Mhm.
Whereas like, a scan engine like a Tableau or a Power BI on the small end of things does, it's basically either, I just want to rip through this stuff one time and boom, and that's like your I only take gasoline, right? And each
Mhm.
engine kind of works a slightly different way. How do you solve that particular problem of these different access methods that would like or that are typically coupled with an engine that's optimized to do things in the way that that language works?
Well, so I'd say two things. One, from what we've found so far, the languages aren't so dissimilar.
Hmm.
Like the fundamental data operations that need to be done, find me things that match, get me stuff, access things, pull stuff out. Like it it's fairly similar. There's some difference in the semantics and how things run, but there are lots of similarities. And so I don't think they're so dissimilar when you get to the actual physical execution of a query. Um, the but the thing I will say is that this is part of the power that comes from kind of defining your decoupled boundaries. So
Hmm.
if we as a company or we as a people building a product believed that we needed to go up into the interaction layer, we would have a bunch of time, people, effort being spent on building out UIs and things and all of that. But when we define our boundaries as
Hmm.
the fewest number of bytes, fastest query, interact with everything, like those are our roadmap items. Make it smaller, make it indexed, or interact with all the things. You get a focus, you get a hyper focus that comes, and we just say, we're going to implement the languages. We're just going to implement them. We're going to find the similarities, we're going to find the differences, and we're just going to go through and implement them. Um, Anybody that's gotten into the weeds of like the logical planning to physical planning of a database will tell you that it's possible to take their physical engine and align it to any language out there. It's both possible and difficult at the same time. But the bigger thing is actually choosing to do it and
Hmm.
actually saying, "No, this is what we're going to do. We are going to do it, and we're gonna figure out what it takes to make it happen."
Yeah, that's pretty cool stuff. It's a good point. It's a complicated sale, but we'll pick that up after the break, folks. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, a fascinating conversation with Eric Tschetter and that's Tschetter, pronounced Cheddar, and Mark Madsen of Third Nature. And Mark, I remember you telling me a long time ago it takes 10 years for a database to be in production before you find the edge cases that will break it. And that's one of the challenges of building a database is that, number one, it's a hard thing to do, kind of to Eric's point. Like you have to be a bold individual if you're like, all right, I'm going to go build a new database. Like, okay, like good luck with that one, friend. And it takes a long while, like from the kernel all the way on up to dealing with race conditions and all this other kind of stuff. You have to figure out how to handle all that. I think what Eric is talking about is very compelling. It does strike me as a difficult sale because you're basically saying, okay, I know you like to use this tool, that tool. We're going to come underneath and be the supercharging data engine that's going to facilitate all these other applications. But I don't know. Maybe I'm wrong. What do you think, Mark?
You're wrong. No, actually, you're right, and
That's
you're
good.
wrong. Um,
Okay, that's good.
what's interesting about that question is, yeah, it is very hard to build databases, and The reason that, relational databases are particularly hard is because they're actually based on a mathematical foundation, relational algebra. Whereas the other kinds of databases, hierarchical databases, pointer-based databases, all these different, well, NoSQL databases, we went through that, we won't go through that era again. But the point of these things is they had different models, but they weren't really mathematically based, so you couldn't prove correctness, you couldn't make guarantees about
Oh,
consistencies in exactly the same ways,
interesting.
sometimes if at all. And so but the point, even with those, is that it still takes you about 10 years because there are so many things that happen so infrequently that you don't experience them more than once a year. And
Hmm.
those are the things where, why did this fail? I don't know. Did you restart the computer? That's kind of the result of those things. Turn it off and turn it on again. Um, but the part I think's interesting in your question is actually also part of the history of databases going way back to the 60s, and that's that, you know, we had files and then we made files that were more structured and we had records in files. And then we figured out ways to delimit or organize those records to optimize performance, to optimize storage, to optimize retrieval, and so on. And those evolutions, gave us these engines. Now, with the log stuff, I think what has sort of happened is that I don't want to say retreated because we didn't retreat, but we built these complex applications like Netflix, right? We built websites, mobile apps, and they're composed not of a couple of programs or one big program that gets a bug and crashes, like Windows. Um, they're things that are many different moving parts, and you can do things like, well, let's pick on Microsoft since I enjoy it. Microsoft Teams, right? And you're on Teams and you're doing something and it's working for you, but I'm frozen, right? Well, why did that happen? I don't know. And there's not just one computer running a set of code with a bunch of people connected to it. There's many computers simultaneously running code, communicating to each other. And then you take apart the server component of that, and it's like, well, it's got these services. And each service isn't just one program. Each service is, like you mentioned, Kubernetes, right? It's a bunch of containers, each running things. So in the old days, we wrote logs to a file on the computer the program was running on, and that was good enough. Now you have 500 computers, each writing logs. Each service is
Right.
writing its own logs. As Eric Tschetter mentioned, it's like every developer wrote their own messages. This should not happen. I literally once got an error on an airline reservation system that said, this cannot be happen. Really didn't know what to do with that. But that is the nature of the complexity, right? And so
That's funny.
we have a kind of complexity that didn't exist. You're generating all these different kinds of logs idiosyncratically. Each individual was doing their thing when they did it. Maybe some teams had standards and others didn't. And you want to do security, you want to do, observability really came out of failure scenarios where we can't just look at one log. We can't predict it. We can't use metrics. And so we have to explore and the other thing is that you fix stuff, but then there's a new failure. Or
Right.
security, you patched this hole, now they're getting in somewhere else. And so it's a constantly evolving thing where you can't predetermine a data model. And that's the kind of complexity that gives you all these different kinds of logs with variable structures that also themselves evolve over time. So they don't even have the same structure from the same application from month to month.
Right.
And that creates a situation that's much more dynamic. And and you have to evolve ways to store, manage, and retrieve that information. And I think that's what Eric Cheddar's really getting at. He's saying, look, we need a new engine. So I want to throw it back to Eric because I am making claims of what you're saying. But that to me is the scenario that leads to a different solution that isn't vertically slice oriented, and it's
Right.
not, I'm going to be the global engine. It's not Splunk plus Grafana plus this, or it's not, I'm going to Oracle all the things.
Mhm.
Throw it
Yeah,
back to you.
yeah, no, absolutely. I think the kind of what you're highlighting, the difference of logs, how they change, absolutely um, it's key to why logs are different. The other thing with the database takes 10 years to get the corners out of a database and all of that. It is true. It's especially true when you're looking at ACID compliance and supporting arbitrary CRUD operations.
Mm.
Um, and the one thing with logs that really makes, and this is true of both observability and security and just the space in general, is that the data is not like you don't want to update it. You want to delete it when someone puts in a GDPR request or something and you need to forget about them, but you don't want to update it because updating it is changing the past. It's
Mm.
changing what actually happened in the past. And the whole point of observability is to know the events that happened in the past and trust that they're the same. And so there is a bit of a simplifying part of infrastructure in this world where the kind of ACID requirements of updates that come with supporting applications with relational databases just don't exist.
Mm.
It's
Yeah,
not.
that's a really good point. Actually, now you're getting down into the workloads of the database engine. But yeah, I would take some issue because having dealt with log structured data, sometimes logs generate bad data, and you realize what the badness was, and then you want to go fix it, and you have to have a way to fix that. The update, if you don't know what CRUD is, it's, create, update, or delete, and it's the update side of that. But
Mhm,
yeah, sometimes you do have to update, but there are mechanisms, as you mentioned, to go and do that after the fact. Unlike a database doing transactions where it's take this one
mhm,
field and update this field. And I think another element of that is that typically with these logs, you're bringing them in, it's more or less one writer, multiple readers. Databases tend to be concurrent in both
mhm.
writing and reading.
And writing, yep.
And then you talked about it's much more difficult because of acid compliance, which is not a drug reference. It's consistency. It's making sure that the bank balance when we both hit the ATM at the same time doesn't give us each the entire contents of the account, but and in this world, we can relax those things because the kind of use case we're dealing with doesn't need to be perfectly consistent over time. It's not going to make that much difference if you see 20 okays and one bad, and I see 15 okays and one bad, right? It's not as important that the data be perfect on retrieval by two different people at the same time. And so to me, these are the workload characteristics that drive different engines.
Well, but so I guess the point I'm trying to make, and this gets back to my earlier point, those are more or less, it's not so much the engine as it's the actual log data type. Anything
Mm.
that needs to deal with logs follow this flow of generally their events, they're generally point in time, they don't change except in kind of extreme circumstances that you want to change them, where transactional stuff is different. But yeah, so having something that's specialized to the data type. So specializing to the data type then turns into specialization in the engine. And the actual query languages also end up specializing to that. And so it's actually possible to specialize all the way down to that specific data type and connect and enable all of the different ways that people do things. Um,
Yeah, and folks, we're gonna have to put a pin in that. I think we need another show planned soon to get to the bottom of this because we're out of time, folks. We'll talk to you next time you've been listening to DM Radio. All right, folks, back here on DM Radio talking to Mark Madsen of Third Nature and Eric Cheddar. That's Tschetter. Look him up on LinkedIn of Imply in our show. What are you implying? That's the title of our show today. And Mark, bring us back to where we were just a moment ago. Go ahead.
Yeah, so I think to sum up Eric's comments, he was talking about how logs are really about events, not transactions. And most of the data infrastructure that we built up over decades was about transaction processing. So, bank balances and inventory counts and so on, where you're recording individual things and each one is important and has value, and replacing that with logs. And the logs are just stored events in sequence. It could be temperature readings, it could be engine sensor readings, it could be, problems with your IT infrastructure. And losing one or two of those doesn't matter, but losing an order matters, right? There's a lot of differences between
Hmm.
this just is a thing that happened, and this is a thing we deem important that needs to be tracked carefully. And then you had databases built up around tracking things carefully and managing them carefully and making sure that everything was where it was supposed to be and that people didn't step on each other. And then you get to the workload of that, which is people working in processes, and the workload of the IT market or the observability space, which is about seeing and understanding what's going on and diagnosing things. And it shifts the workload a bit because logs just show up. They come, they're constantly being output. They don't tie to this business process in exactly the same way, and they're all different and random. And so that leads to a kind of workload of stuff being recorded, and then once in a while, people have to go in and dig through it to figure out what's going on, diagnose a problem, troubleshoot something. And then once they've discovered something that it's like, oh, we should track this, that gets thrown over the fence to the repeatable side, right? And the repeatable side is what we use databases for in business intelligence and transaction processing. And so there's kind of an interesting twist to workloads. And I'd kind of like to hear Eric talk about how to deal with that problem because it is a problem.
Yeah, no, it is a problem, but I think that problem is also the fundamental kind of realization that we came to is that if you if you think of the data infrastructure and you think of all of these problems in this decoupled manner where you have some interaction layer sitting on top of some data layer sitting on top of some data acquisition, you realize that the everything in that interaction layer, all of the things that people are working with, they're interacting with, that's where all of that workflow is codified. That's where all of the things that people need to do has actually been defined. And those products in that space have gone very deep in kind of building value and creating value and making sure that they're aligning with the end user workflow. So for logs, it's as was mentioned, kind of correlating things. You find one thing, then you need to find another, then you need to find another from that one and jumping. And for different data types, it ends up being different. And so like those workflows are definitely different. But at the end of the day, they also all turn into a query. It always turns into that interaction layer generates something that wants to then say, hey, does this exist in the data? Hey, can you add these things up for me? Hey, can you do this or that or the other thing? And of course, as you align with different workflows, the shape of those queries becomes different. And in this world, there's been a number of different kind of query languages that have been created in order to support the different workloads. And so aligning with the workflow, aligning with what users are doing with the data really comes down to one, leaning into what's special about the data in logs, the fact that it doesn't change, it's immutable, the fact that you're just wanting to kind of arbitrarily search for things. And that it's leaning into that, the fact that there's no schema, it's relatively schemaless, it's leaning into that in order to reduce the number of bytes used to store it, but then also connecting with whatever query language or query layer the actual end user is interacting with. And when when you think a lot of times that ends up getting clumped together, and the interaction layer and database are very tightly coupled and running with that. But what we realize is that doesn't have to be the case. That these query languages, it's possible to lean into the shape of logs and lean into just connecting up with the different query languages and enabling kind of whatever the end user workflow is. Um, and that's kind of the thing, that's kind of the nugget that we realize, is that then unlocks so much more for people who want to use their logs for all sorts of different things.
Hmm.
Yeah, I think, in a way, it recapitulates the origins of relational databases. A lot of times the query language was coupled to the database, and it was coupled to this front end that operated on the thing, and it was this nice tight stack that was great as long as you stayed between the lanes. If you
Uh-huh.
strayed from your lane in, an old mainframe database like IMS or something, then you were in a world of pain, right?
Hmm.
And then that was true of the NoSQL period of say the 2010s, which isn't that far in the past, but they all came, they were going to replace the world, and then it turned out that each one was its own special snowflake, and nothing survived that. And well, not nothing, but there was one standing in each little domain because of that tight linkage. And I think that goes back to the very beginning, which is in the observability market or the IT ops market, or however you want to look at the market. We were talking about Splunk versus Grafana, and
Hmm.
that there were choices of stack, and
Hmm.
the front, the middle, and the back were all locked together, and you have basically no choice, and you're trapped in the swim lanes.
Hmm.
Yeah, that's wild. We only got a couple minutes left here. And again, look these folks up online, Mark Madsen and Eric Cheddar. Eric, would you call Imply a time series database?
No, and well, so in the Imply Lumi product, which is what we've been talking about, no, I would call it, it is an observability warehouse is the term that we're coining for it, but you can think
Hmm.
of it as a warehouse, a data warehouse, or a data lake specialized for logs. And so you could also call it Snowflake for logs if that's resonates more, but it's something that really is focused on
Yeah.
logs.
So real quick, Snowflake focused on logs. Are you then capturing the results of certain interactions and then storing that almost like a playbook, how they do in security or in troubleshooting, meaning when this log fires, then that log fires, and this other log over here fires, that means this happened. Is that something that you're tracking over time and using to build out a sort of playbook?
Yeah, so that is and that is part of the interaction layer. That's part of
Right.
what users are doing. That's part of the workflow that gets defined on top of logs.
I see.
And so that is built, and people have built that into the tool that they're using to interact with their data.
Like Splunk or Dynatrace or
Right,
whatever, right? I
or
see.
Grafana or whatever. Like they've built that in, or with AI agents, agentic things are taking over a bunch of that as well. But in order to actually do that workflow, it has to query the data and see if the thing happened. It
Hmm.
has to see if the thing happened. It has to see if the next thing happened. It has to see if the next thing happened. And that interaction with the data and that decoupling of that interaction and that workflow from the choice of where how you store the data
Hmm.
is the primary thing that we're driving after with,
Right.
yeah.
And you're the enabling technology underneath to really facilitate all those workloads is the idea, right? And you're
Yep.
also the idea is you're feeding not just security, but also
Mm-hmm.
governance, compliance, like whoever else
Yep.
wants
Yep.
that, you're enabling that, which gets back to one of our initial discussion points here, which is like a lot of stuff is the same. It's got a different name, maybe a different purpose, but
Right.
still trying to accomplish the same objective. Well, folks, what a fascinating conversation. Look up Mark Madsen of Third Nature, Eric Cheddar of Imply, and yourself. We'll talk to you next time. You've been listening to DM Radio.